Welcome to our new webinar. Today's webinar is called Digitalization of Drilling Operations. Together with me I have Sven Inge Ødegaard and it's myself, Morten Svendsen, who will go through this webinar with you. So, what's happening in digitalization at the moment? What we see now today is that it's not only kind of the engineers who is talking about digital work processes, it's actually all the way up to the CEO level. And what does that mean for us? That actually means that there will be fundings and money to actually run digitalization processes. So, and if we look at all the engineers, or actually the people kind of working in the digital world, what is our focus on that? And what are we thinking about digitalization? And what we see is that there is a lot of different thoughts about what actually is digitalization. Some are talking about having data available in a digital warehouse. Some is talking about digital work processes. So there is many different approaches to what is actually digitalization. So, what is digitalization? It's a good question. We have to apply some technology related to this. From our side, we have talked about the virtual well or the integrated drilling simulator ever since the start of the 2000. But today it's a new word that's coming around. It's called the digital twin, and the digital twin represents the well digitally, so that you can do forecast, real-time simulations, automated monitoring, and so on. The digital twin is an integrated drilling simulator that has a hydraulics model, it has a temperature model, both need to be dynamic, of course, and a torque and drag and an ROP model. And the important thing is that you have an infrastructure that enable these to be used in all of the different operational phases, from operation, pre-planning, planning, engineering, training, and so on. The digital twin also, in our view, composed of a virtual well where you can actually see what's going on. You can see the risk picture, you can see your real-time data, you can see your simulated data. When you have a simulated data of a simulated well, it's very easy to do forecast and what-if scenarios, and use those again in your work processes to be able to optimize the operation. So from our side, you need one integrated solution for the entire drilling process to be able to get to the digitalization. So one model that fits everything that you can use for all the operational phases, from planning, design, operation, after operation, and of course preparations. So this is this is Statoil digitalization roadmap. They have defined 7 different areas where they're going to do digitalization. One of them is to be able to utilize data for planning real-time analytics and increased automation. We are involved in this, and Morten's going to give you a bit more about the details. So what's different from what we have been doing for the last 30 years or so and what we are doing now? What we see is that everybody is doing what's very often called advanced monitoring or something in that area. And the focus there is to look at the real-time measurements from the rig and compare that to simulation results that you have been doing prior to the operation. And from that, you use people or engineers doing manual diagnostics. They can also run some new simulations if some changes have been done. But if you look at kind of what we are working on at the moment, and we have been doing since kind of 2008, is what we call automated monitoring. And again, there you have real-time simulations driven by the signals or the drilling data from the rig, and then you compare the simulation results in real time with the measurements that is also done in real time. And that enables that you're able to do automatic diagnostics on top of the manual diagnostics, and do self-detection and detect different operational statuses or problems in the well. And the next level, as we see it, is what we call the real-time optimization. And by having a framework where you are running real-time simulations and do diagnostics on it, you're able to do also forecast simulations, forward-looking simulations, what-if simulations, and do predictive analytics. So kind of if you have an event occurring in your well that is detected by the system by a kind of automatic diagnostics, the next level is actually to run a what-if simulations on how to solve this problem. And this is kind of where we are kind of looking into more and more at our clients. They want to do more advanced or real-time optimization of their drilling and well operations. So a bit kind of where we have been doing automated monitoring and real-time optimization. And we have clients like Statoil in Norway, CNOOC in China, and Wintershall, where we have been running a lot of real-time optimization. And this is just kind of some of the rigs we've been on, and a lot of these areas Statoil, but you also have some rigs in China, and you have the IMSA at Wintershall, for example. I just wanted to kind of talk a bit about kind of the diagnostics, which is kind of the next level from kind of just having simulations. And we call it kind of real-time diagnostics. And the basis of this is, of course, historical data, but again, the real-time measurements and the real-time simulations. And what we are using our diagnostics for is to kind of detect operational statuses and also to detect downhole problems or changes. On the right side here, you can see we have implemented for one of our clients. We are kind of writing or making or we have integrated us to their system, which they use to look at operations. And here you can see that we are writing messages back that here's an example with the calculated ECD below pore pressure prognosis. And below here you can also see the same thing in our 3D environment, that the message is appearing at the depth where it actually happens. And again, this by using kind of automatic diagnostics or notifications, you can enable, as I already said, automatic what-if simulations and automatic forecasting based on the changes that you have been doing. What we see kind of at many of our clients or oil companies that kind of has done success in digitalization, or actually are on the way of doing a success, is also that they are looking at digitalization is kind of the digital process on digital data. And what's important there is that data is available for all the processes. And that means that if you have many kind of systems working, or if you have, for example, have many software tools or simulation tools, you can make sure that you're able to do simulations on the same data, on the same basis of data, and you can share data between them to make sure that all simulations is always updated. And what we see is that to do that, all applications or processes runs in the same infrastructure, or at least have access to the same data store.
by having an open and common API. And as you see, also all application process outputs are written back to the common data store. So now we would like to kind of show you some of the applications that we use to kind of enable kind of digitalization in the drilling operations. So first of all, I will show you a very kind of normal plotting tool, which kind of everybody is using something similar to this. But here you have, for example, and this is kind of a demo well that we are running on. So it's a bit quicker than real time. And what you see here is that we typically have normal things that we plot, but we have the measured ECD, but we also have calculated at the PWD tool, and we also have at the casing shoe. And the same thing with standby pressure. So we have the measured standby pressure and calculated standby pressure, and you can compare them in real time. And this goes on for not only kind of hydraulic simulations, but also for kind of torque and drag simulations and so on as well. We can show here, for example, we have some modeled hook loads compared to measured hook loads. As you see there, here are probably some more friction than actually should be in the well. But let's look at what we think is kind of the next thing, which is kind of what we really kind of have been working on since the beginning, is to be able to show data in a new way and kind of get rid of the squiggling lines. As you see here, this is you can see many wellbores here, and you see kind of formation tops and everything here in a 3D environment. But what's really interesting is if we zoom in, you have the real-time rendered drilling operations. So here you see that you have your bit rotating, and we are moving downwards in the well. Here you also see that we have sensors along the string or along the wellbore. So this is kind of what we are looking at here is kind of the bit that is what we get from the real-time data flow. But the ECD here is our calculated ECD at the PWD tool. But we could also add the real-time, the measured ECD and so on. If you zoom a bit out, we also see we have a plot along the wellbore. We have the temperature along the wellbore, and we also have the cuttings. There are really very little cuttings in this well, so it's not giving any good information. On the other side here, we have you have a typical notifications that we add along the wellbore that gives you a kind of a possible to see the data along in a real world instead of just on kind of on a message. If we go a bit up here in the well, we can also go up to, we have other messages. Yeah, so here you have the casing shoe. So where we also have the all-time modeled ECD available for all operations.
You will also be able to see all the BHA elements going through the casing shoe, so that you can see why you get frictions and so on.
Yeah. So here we are combining historical data, we have measured data, we have model data, and by that we are actually utilizing all the kind of the digital data that's available in one screen.
So this is the digital twin running together with real-time data and of course historical data.
Yeah. So I think we are we were not we didn't plan to kind of talk too much about this, and we have kind of given you a teaser about what we are looking at. If anybody has some questions, you can ask questions in the question box in the GoToWebinar applications. And we have already got a couple of questions, so we can start by going through those. And one question is about the digital twin. Yeah, okay, how long time does it take to create the digital twin for our operation? And that's a very good question. We have an infrastructure where we are running everything in cloud servers. So we are starting a cloud server kind of quite easily up, and if the XML data feed is good and the data is available, we should be up and running in matters of hours. A couple of hours we should be ready. So. And that's a big kind of difference from before. We are quite quick and should be able to go into an operation as quick as possible. Another question is, has your technology led to any changes in workflow at any of your customers? That's a good question as well. What we have seen that at some of the customers that has been using our technology, kind of the digital twin, have actually changed the kind of the decision matrix. So they have been able to make decisions based on data available during the operations and be able to do the decisions quicker.
So typically they based the next operation phase on forecast simulation done with the system. So they could update maybe the cement program hours before doing it, based on the forecast simulations.
Another question, will a driller have access to this? For example, notifications of upcoming hazards. And that's also quite interesting. And the answer here is actually up to the clients of who is going to have access to this. What we have seen is that some new clients, they actually have this 3D visualization available for the driller on the drill floor. And that gives them the possibility to kind of have a different view on the well, but also get all the kind of notifications up. And we also have some clients that is kind of only using their own visualization or their own plotting tool, but then we are writing our diagnostics back to their system and make it available there.
By presenting this kind of information from the driller, he will move the focus to downhole instead of looking at the Martin Decker watch or looking at the drawworks going up and down. So we think this is a game changer for the industry to focus more on what's happening downhole and look forward.
Yeah. So we got another question. Can you take a data feed from a third-party model and use your digital twin? And that is a very good thing. We have our own kind of hydraulics model and torque and drag model and so on that we use to represent our digital twin. But our infrastructure allows to take data from any third-party model and also run that in our system and make it available. So you could use our system to show you real-time data, our model data, you could show a third-party model data and so on without any issues at all. Will logging info from drilled offset wells be visible from all logging vendors? And that is quite interesting. Yeah, we have in our 3D visualizations, we have had a big focus on the active well, on the well you are drilling. But it's possible to add informations from all in the area around you. And we have been doing that for some of our clients, and that has been quite successful. And very useful because since we are doing this real-time rendering, and we can update the well path with the measurements while you are drilling, you will also kind of have a good view on your anti-collisions issues. Yeah, can you plan the well against other wells for collision monitoring and projection ahead. Yeah, we don't have an anti-collision module, but we are visualizing this in our 3D application. So we can import all the wells in the area and have the updated well path while you are drilling. So there is a possibility for it, but we don't have a kind of a anti-collision module.
No. In our roadmap, we have both casing design and well placement as parts of our software roadmap.
Yeah. So that is coming, and it's quite important for us to be able to actually deliver a proper digital well. Yeah, another question. Can you use the system with wire drill pipe? Use multiple real-time measurements along the drill string? Yeah, we have been doing some pilots with the wire drill pipe earlier. We can visualize the data along the wellbore. So you have the measurements that you are getting from the wire drill pipe, but you can also have our modeled on the side of that.
Actually, wire drill pipe and good measurement will enable even better simulations from our side. Then we can do even better forecast and what-if simulation, because that's what you need, is to be able to look ahead and then use the data that you get from wire drill pipe and then optimize the models and be able to do better simulations.
As data quality is generally poor in drilling, do you see this as a way of improving this in the industry? Yeah, we have seen a lot of strange things when it comes to data in the drilling industry, and if you look at a history of it, we know that many oil companies, they store their historical data in file structures, in PDF files, and in formats that's not very good. But we see that there has been, first of all, if you look at the real-time data, that has been quite good for a long time, and we haven't had any kind of big issues on real-time data. But what we see a change in the industry when it comes to storing all the other data and make it more available for different vendors. So we see that that is actually happening, and that makes it much easier to introduce kind of new technology.
And also when you have a digital twin that's simulating your data, so many operators, we see that they have poor data for hook loads and weight on bit and so on, and then the focus is then to get better sensors, because they see the model data all the way, and then they see the big difference, and then they start to use energy to actually get them better, so that they have a better data to compare with.
Yeah. So another question: does this not then give a false sense of security? It appears accurate on where you are drilling, but the uncertainties are not shown. And that is kind of true, because we are always modeling how the well should be. And that is the kind of the important thing here, that in real time we need to do comparisons. We need to do comparisons towards the measurements versus modeled. And that is what we are using to trigger diagnostics. And by doing that, since we're doing it on a kind of with computers instead of with people, we are able to detect things much earlier, very often, than you do normally. And then you're able to actually do something about your problem before it actually is there.
Because you can say the uncertainty maybe is the difference between model and real-time data, and then you have a visualization of your uncertainties also.
Yeah, and there's always uncertainties, and that's when we do kind of ECD calculations, we always compare it with the pour and frac prognosis and the collapse prognosis. But that's always also just prognosis. So there's an uncertainty there in itself. But since we are doing that, we can have really good control if you are within your prognosed window, and again also look at the measurements if something is about to happen as well. Can you import experience from neighboring reference wells into your digital twin? Expected challenges, hazards, for example. Yeah, when it comes to the modeling, we are not taking all kind of the hazards into the modeling, but we import, or we kind of get in kind of issues that have been on neighbors' wells. So we know that if there's a formation top that is a risk, there's a possible fault, or there is a string or something like that, that is data that's available and is visible for the users. But when it comes to the modeling, we don't kind of take all that risk elements into it, because we are trying to explain how your well should look like. Do you see an opportunity of your approach to the world of P&A? And yes, that's quite interesting. When it comes to P&A, there is a lot of interesting operations that's performed. And when it comes to kind of moving things up and down in the well and do simulations on that, that is quite interesting. We are not into the area of kind of cutting casing and pulling it out, but for simulations on kind of the surge swap effects, if that's interesting, that of course, but also for kind of visualization to show where are you in the well, where are you compared to the different downhole tools and so on. That is very interesting. So are you missing any types of data or information that would help, particularly in the area of predictive analytics or look-ahead capabilities? At the moment, we don't actually miss anything in particular, because we have pretty good. We are getting more and more out. The data sets that we are getting are being better and better. But of course, to do kind of predictive or forward-looking capabilities, we need to know a bit more of what's happening down there. And today, most of it is kind of, as I said, it's pour and frac and collapse pressures, and that is very often available. Yeah.
But also, of course, better data on the flow is appreciated. So a better flow out measurement would be able to help us to detect things even quicker than we do today. So that's kind of the signal that we see that the poorest quality of. It's good when we have MPD operations where you have a proper flow meter, but in more traditional, the industry needs to be able to measure flow out better.
Yeah, and we are also looking forward to that kind of all rigs get real-time rheology readings and proper density readings.
Yeah.
We see very often now that it's manually input with the density, and also kind of very seldom rheology updates. That gives kind of a possibility to do some not that accurate simulations, but we see as more and more rigs get these measurements, we are get even higher quality on the simulations. Okay, we are now in exactly 30 minutes. So if you have any other questions, please feel free to contact Sven Inge or me, or any other in eDrilling, and we will try to help you as we can. So thank you all for joining us, and have a nice day.
Thank you.